Friends, this is PPH 3802 Unit 2 Nanoscience by Dr. M.R. Gadhvi. In the present unit, we will be focusing on the nanomaterials and their science and their technology too. What it mean by nanoscience? Nanoscience is a concern with the material and the system whose structures and components exhibits novel significantly improved physical, chemical, and biological properties, phenomena, and the processes because of their small scale or the nanoscale in the size. There is a one very special structural features is also observed. And what is there? The structural features in the range of the about 10 angstrom to the 100 angstroms, or you can say the 1 nanometer to the 100 nanometer. I repeat, 10 angstrom to the 1000 angstrom, or 1 nanometer to 100 nanometer is the structural features which determines the nanoscale. If your material is larger than the 100 nanometer or the 1000 angstroms, which is referred as the bulk material, or in general it's larger than zero point 0.1 micron. Right, so nanoscience means aims to understand the novel property and the phenomena on the nano-based entity. What happens when dimensions structures reduce to nanoscale or nano level? बड़े से बड़ा particle है, large like you have a larger rod of iron and you have a nanoparticle of iron. What is the difference between them? So this science is referred as a nanoscience. We are comparing the nanoscale with the bulk size and how the properties are varied and what are the phenomenon varied and how the properties are significantly changes. That's something interesting in the case of physics, chemistry, and the biology as well. Now the classifications of the nanoscale is also possible on the varieties of the at varieties level. Over here we wish to do a classification on the basis of their dimensions. Okay, so the material which are outside the nanoscale, so on that basis the dimensions will be defined. So one dimension is outside the, two dimensions are outside the nanoscale, three dimensions are outside the dimensions, and so on. So in the zero dimensions, it's very well known that it's a one dimension, two dimension, and three dimensions are very well known terminology for all of us in during the undergraduate as well as the school grading. But let us try to understand in the nanoscience what it means exactly by the zero dimensions, one dimension, two dimension, and the three dimension. Zero dimension, that means you can touch the particles individually, you can see their individuality, they are easily moved, you can able to tackle those particles. It may be a single particle within the range of 1 to 100 nanometer, or it may be a group of particles, but they must be an independent entity. It should be the point like structure, then it is referred as a zero dimensions. Accordingly, in the zero dimension, that is a 0D, nanomaterials, all the dimensions are measured within the nanoscale. माने अगर हम dimension की बात करें तो तीन dimension है, x, y and z. तो तीनों dimension we will be in capacity to measure in the nanoscale. माने all are in the range of 0 to 100 nanometer or 10 angstrom to the 1000 angstrom की रेंज में ही होंगे. And very commonly we can say that the well known example is nanoparticles, quantum dots, correct? These are the well known examples. Let us check it one dimension, and there is it is written it's a quasi two dimensions. That means there is a two quasi dimensions, and so quasi, that means it's not certain, right? And one dimension is a fix. So if you look at it's kind of it's a flange, it's kind of a, let us say, a rope, it's kind of a string, it's kind of a filament, it could be a rod. These all are the very well known and good example of the one dimensions. What it mean by one dimensional nanomaterial? That means one dimension is outside the nanoscale. And if you look at here, it could be long sufficiently, maybe a nanometer, 100 nanometer, 200 nanometer, something like this. So it is uncontrolled. Whatever the length you may have, it's depend on your methodology to prepare the nano rods or the nano wires or so, right? If you look at the diameter wise, then it is definitely a nano. The length wise and height wise, it could be, let us say, this is a strips, right? Here it's a circular, it's a road, so I think x and y, the cross sectional area is almost uniform. But if it is like a strips, then the height is different, length is different, maybe not in the nanoscale, but yes, one scale is definitely within the nanoscale. Two dimensional, in the two dimensional nanomaterial, two dimensions are outside the nanoscale. This class exhibits a plate like shape. एक अगर प्लेट है तो उसकी दो साइड अगर आप देखो तो this length could be anything, this length could be anything, but thickness is, let us say, always in the nano scale. So two dimensions are outside the nanoscale. Length कहीं पे भी हो सकती है, width कहीं पे भी हो सकती है, maybe within nanoscale or maybe a larger nanoscale, but on an average it's found to be a larger nanoscale, and therefore it is referred as a two dimension. और यहाँ पे एक ही dimension फिक्स है, so it's a quasi one dimension. सो एक डायमेंशन तो आपको 100% नैनो मिलेगा, दो डायमेंशंस आपको आउटसाइड द नैनो स्केल मिलेंगे. यहाँ से एक स्टेज हायर, यहाँ पे क्या था, यू विल बी हैविंग अ वन डायमेंशन इज आउटसाइड द नैनो स्केल, दैट मीन्स टू डायमेंशंस आर विद इन द नैनो स्केल, करेक्ट. सो अगर यहाँ पे देखो तो x and y axis both are, that is a diameter of this one, length is unpredictable, so it's a one dimensional case. Two dimensional case, that means what are the examples? Graphenes, nanofilms, nano layers, nano coatings. अगर आपने देखा होगा तो nowadays the goggles what we are wearing, that is having a nano film coating. शायद आपने सुना होगा काफ़ी एडवर्टाइज में, आई डोंट वांट टू अटर द नेम ऑफ द कंपनी, बट those companies are giving a coating on the specs, coating on the lenses, and that is a nano layers, right? So this is two dimensions, that is in always in the layer formation or a two dimensional part. Here it's a one dimensional part, okay. And very understandable, one dimension is outside the nanoscale. यहाँ पे two dimensions are outside the nanoscale, so that would be this one. Three dimensional, that means all the three dimensional materials are not confined to the nanoscale, that means x, y and z all are outside the nanoscale, so it's a huge material, right? But still we defined as a three-dimensional nanomaterial. What it mean by this? So they are assembled like anything, right? It, you can look at here, 3 3s are 9, so it's just like a cube. So it's a cube, and within this cube is cubelets, the small cube, that each one is of a nano size, but they stuck together, they remain together, they hold together, and therefore this is referred as a 3D particle. They are remain in a lump, they are remain in a assembled order, they are remain within a matrix. It could be anything, but the outcome or the nutshell out message is they each particles, if you are talking about, then definitely they are in the nanos range. So how I will give you the example. This class can contain the bulk powders, but powders particles are definitely of a nanoscale. Dispersions of a nanoparticles, मेरे पास particles है और मैं उसको पानी या तो oil या तो any liquid के matrix में या तो solid में disperse कर रहा हूँ. So that would be the uh, dispersion of a nanoparticles. Bundles of a nanowires, अगर एक दो वायर अलग अलग है then you can definitely put it into this one in a one dimensional. But let us say you have a something like a rope type structures, a bundles of a nano wires, then that would become in the three dimension. Same way you having a one or two or three layers of a nano range, that will be in the class of a two-dimensional uh, nanomaterials. But suppose you having a plenty of layers of such two-dimensional layers, then that would be a class of or you, I mean to say, the multi-layer stack, that would be referred as again three-dimensional. You having a nanowires, bundles of nanowire, bundles of filaments, bundles of nanotubes, bundles of all will be class of the all will be the class of the three-dimensional one. Fullerene, again it's a zero-dimensional because it's a point like a structure. One-dimensional carbon nanotube because it's a one of the uh, dimensions are outside the nanoscale. Two dimensions are within the nanoscale. 2D structure, that means two dimensions are outside the nanoscale and thickness wise it is within the range. So it's a one, so it's a quasi one, or you can say the two dimensions. 3D, that means it's again on an average it would be a assembly, it would be a self assemble, it would be a guided assembled, but in short they are in the it looks like a bulk, though they are individually nano, but they are representing in the bulk or the assembled fashion. Okay, how, what are the examples? Examples are the bundles of a nano wires. एक दो वायर अलग नहीं है लेकिन just it is sometimes it's also known as a rope of the nano wires. So something like that. Nanoparticles, but not individually, but they are in the powder form, and some powder particles are mixture of a 5-3 crystals, so that is grain is larger, some grains are smaller. A new word you will be learning rather in this one is, yes, so before I start the new word, that is a grain understanding, let me having again a few examples of a three-dimensional, two-dimensional and one-dimensional. Fullerenes, colloidal particles, nanoporous silicones, activated carbon, nitride and so on. These all are the three dimensions. So अगर आप देखो तो nanoporous silicon. So if you are having a silicon slide or kind of so a piece of a silicon, but when you look at in a microscope you are finding there are plenty of the porous holes are there. So basically a porous assembly is there. Each and every individual size of the porous region is of definitely nano, but they are in the assembled form, so they will be put it into the class of a 3D three-dimensional nanomaterial. Carbon nanotubes, nanofilaments, metal, these all are the two-dimensional. Nano main composites and material, green boundaries, film, clay pellets, semiconductor, magnetic materials, Langmuir product film. I think here the dimensions are changed. I think this should be the one dimension and this should be the two dimension. So, oh, okay. The word is different here. It's written 2D confinement, so there is maybe a two dimension is confinement. Okay, so if I say it's a film or boundary or something like that, or an rod like structures or nanowires, that would be a one dimensional, and this would be the two dimensional. Okay, though it's a part of book, but I think it's a misprint. This it is a it should be as it is mentioned here: the nanotubes, nanofilaments, magnetic nanowires. These all are definitely class of one dimension, and this will be a class of a two dimension. So if guys, if you are preparing a note, please recorrect it. Okay, now the nanoparticles may be quasi crystalline. So what it means, so whenever the word is quasi, you should be remembered it's not a permanent one. So quasi, that means how shall I understand the crystallinity? Crystallinity may be a long order orientation of a particle, or the periodicity for the long order. But if you do remember your fundamental solid state physics, then you having a two fundamental classes, amorphous and the crystalline. But in between that two, there is a one more class, and that is known as a glass. Do you remember that? It's a glassy structure. That means there is a order, there is a crystallinity, but it is not for a long ordered. Okay, so this is similar thing is observed even in the nanomaterial, though it looks like a crystalline, but the order is not too long range, and therefore it's referred as quasi crystallines. So some examples they have given, that atoms or the molecules are packed together in something like a icosahedral arrangement. This is example is given over here, icosahedral, or even the fullerene ball is also a good example of icosahedral. Basically, icosahedral word came from the icosahedron, and this icosahedron, that means there is a 20 or more than 20 number of the faces. So यहाँ पे अगर आप ध्यान से देखो तो ये एक ट्रायंगल फेस है, राइट, और वो सब ट्रायंगल को अगर आप मिलाओ तो आप और एक हेक्सागोन रिंग बन रही है, उसमें 6 triangle faces है, and this all 6 triangles, so such kind of the many planes are makes this ball. And यहाँ पे एक 6 का पैच है, यहाँ पे एक 6 का पैच है. So that way there is a polyhedron, and that polyhedron is some around more than 20 identical equilateral triangular sides, and this is uh, referred as a icosahedron. So icosahedron शेप में बहुत सारे नैनो पार्टिकल्स को विजुलाइज किया गया है. सो इट इज़ नॉट ऑलवेज रिफर्ड एज अ नॉन क्रिस्टलाइन वन, but their crystallinity is for the shorter range. Okay, but yes, to be rigidly stick to the solid state physics, then you can definitely put it into the class of a non-crystallinity symmetry. uh, so this is what the mean of the quasi. So अगर डिसेक्शन कर ले वर्ड्स का तो ये हो जाएगा, it is a quasi crystalline. This is a very interesting word. That means the order of the crystallinity is not for the longer phase or longer range. It has observed that the nanoparticle have a specific morphology and may have a certain crystallographic orientation relationship with the matrix. So kabhi the three-dimensional class of the nanomaterials, that means they are not remain as an individual, but they remain stuck together. They make a lump or they make a powder type structure, so you will finding them in a polycrystalline material. Okay, so let us say you are dispersing them in a, let us say, liquid matrix or maybe a oil matrix. So you have a powder which is hundreds of nanocrystallite materials are together, and this powders when you disperse into a liquid, so it is liquid is certain, any particular liquid is a matrix, and the powder itself having the nanoparticles. So such kind of where you will find it out the self assembled quantum dots or a nanoporous materials and nanopores and so on are the very good examples of this one, where you are observing a kind of a non-crystallinity, but still it is observed that within a matrix you are finding them, they are arranging them their self in a almost crystallinity will maintain up to a certain order. So ultimately again it will touches to the concept quasi crystalline. Okay, the next I think stop here, and this is just a brief idea about how a nano material can be classified in a three category, and that is uh, what we have seen today. Thank you so much. Stay home, stay safe.